All right, let's begin the review. Hello guys, hope you're fine. Let's just jump right into it. Sorry I'm a few minutes late. I just ended a review with another class and I rushed over here. So without further ado, let us jump into the review. And as always, I'm gonna just turn off my camera just to kind of reduce any lag here. And we can be off. So yeah, ask me whatever. Let's go. This is where you guys take it away. You guys are directing. Anything that you felt off about or you want to talk about? Oh, actually, there is something that I want to start the session off with, actually, because Syed told me that he couldn't make it and he wanted me to go over problem 9. So let's actually just run through problem 9 to get this thing kicked off. And then we'll kind of go into whatever you guys want after that. So hopefully you guys don't mind me doing this problem. There we go. So hopefully everyone can see the problem there. All right, so this is problem 9. Plane contains 3 points, P, Q, and R. You are to find the vector P, Q, and PR. Find a vector that is normal to the plane P, Q, and PR. PQ. That's normal to the plane containing PQ and R. Find the area of the parallelogram and find the angle between PQ and PR. You may leave your answer in terms of inverse trig functions because, as you know, you shouldn't be using the calculator, so you're not going to get a decimal answer, an exact answer. You should leave it as in terms of trig functions. So let's actually just run into this. So A. I am assuming that this is not going to be a problem, so let's just run into it. PQ. So PQ, remember, it just means you do the whole final minus initial idea. So you would take, the Q is the final point, so you take the corresponding coordinates of Q and subtract the coordinates of P. So it's 2 minus 1, comma, 1 minus a minus 1, comma, minus 1 minus 0. So that is 1 comma 2 comma minus 1. Okay, so that's like the final minus initial idea. So that's how you'd find PQ. And then for PR, same thing. So it's the R coordinates minus the P coordinates. So it's minus 1, comma 1 minus a minus 1, comma 2 minus 0. So that's your PR. And there we go. That's 2 points in the bag. How do you find a vector that's normal to the plane? So we actually discussed this in our last lecture. You had these 3 points here. Like you had your P, you had your Q, you had your R. And what did we do? You guys remember the solution? One of you came up with it, so. Okay, so we would create 2 vectors in the plane. And it's already nice. I already asked you to create 2 vectors in part A, so you already have the work done for you there. And then to find something normal, you can cross product them. So this is in fact PQ cross PR. And you can go the other way. You can do PR cross PQ. That will give you the one that's going in the opposite direction, but it's not going to matter. This is PR cross PQ. So you'd create the 2 vectors in the plane. You'd take the cross product to get a normal vector. So we have here. So I can just find a normal vector. I plugged out my tablet. I forgot to plug it back in. All right, here we go. So the vector is normal. I'm just going to say PQ cross P. And remember, you line it up like that. And again, remember for the I, block out everything in that row and that column and find the determinant of the other two guys. So it's going to be the 2 times 2 minus the -1 times the 2, which is +2, comma. Then you block out everything in the so you have 2 plus 4. And so this would be 6, comma 0, comma 6. And that's a vector that's orthogonal to the plane. It's normal to the plane. Find the area of the parallelogram. Well, we know that the area of the parallelogram, there are a couple ways you can do this. And let's see, for D, the angle between the two, we would use the formula. We know that A dot B is equal to AB cosine theta. So this means the theta is going to be the cosine inverse for this one. And of course, our vectors A and B are really the PQ and the PR. So it's going to be the PQ dot product with the PR over the magnitude of PQ, magnitude of PR. Where? Now our PQ, PR.
Professor?
Yes.
I'm not sure if it cut out for anyone else, but can you go over area of a parallelogram again, please?
Oh, so part C?
Yeah, it just cut out. And then it...
Okay, so the area of the parallelogram, you can remember this is also the magnitude of the cross product equals the area. Well, it equals this. The other way you can think about it is doing the magnitude of A, magnitude of B, sine theta. But I think if you already computed the cross product vector, it's just easier to find the magnitude of that vector. You'll actually get exactly the same answer.
All right, thank you.
So this is going to be, but of course, in order to use this formula, you'd have to know the angle between them, which is what part D was about. So this is probably the only way you could do it at this point. So remember the cross product, that was one of its definitions. It is a vector that's orthogonal to two vectors, and its magnitude is the area of the parallelogram formed by those two vectors. So if I want the area of the parallelogram, just find the magnitude of the cross product. It's going to be the same thing. And for this one, this is a formula that we actually had already. So in this case, our PQ is the 1, 2, minus 1. 6 square root of 2 squared is 4 plus 4 plus 4 is 12. So, and I mean, you can leave it like this. I mean, at this point, I wouldn't take anything too crazy. So, but this is minus 2, 4. Minus 2, 4, minus 2. Oh, that's cosine inverse of 0. So this one you actually know. All right, so the angle between them is pi over 2. So these two vectors are actually orthogonal. So there's actually a 90 degrees for between these guys as well. Nice. And so that would be the answer. So something like this. You have a plane that contains 3 points. You can find the vectors of that connects different points by doing the final minus initial in the coordinates. If you want to find something orthogonal to a plane and you have 3 points, you can connect 2 vectors to it to create that guy with a cross product. The magnitude of the cross product is the same as the area of the parallelogram, and this formula can help us find the angle between 2 vectors. So this was covered in between the last 2 lectures. It's problem 9, and I believe so. Hopefully that was okay. And of course, I'll post the PDF of this when I'm done. I believe there was another. Yes, Caitlin, do you have a question?
Yeah, I have a question about another problem on the practice test, like a different one.
Okay, hold on, let me pull that up. Okay, go, tell me your question.
So for number 6, like the radius of convergence and the interval of convergence, I keep getting
Okay, hold on, let me actually do a screenshot of that and post it here.
Okay.
Okay, so problem 6. So how do you find the radius of convergence?
You do the ratio test, right?
All right, so it's by the ratio test. So by the ratio test, you are going to actually compute L, which is the limit as n approaches infinity of an plus 1 over an. So you're going to go into here, you're going to plug in n equals n plus 1. And then you divide by the original. And at this point, you can start to simplify some stuff. This whole thing here cancels out with that. This whole thing here cancels with that. And so we have 1/2. Then we have ln of n over ln of n plus 1. Then we would have x plus 2. And what's the limit as n approaches infinity of ln n over ln of n plus 1?
1.
It's 1, right? So this part here is going to go off to 1. And so now this limit just becomes, well, x plus 2 all over 2. And then you set this less than 1 for convergence. So now you would get that your x plus 2 is less than 2, which, by the way, this already tells you that the radius of convergence is 2, but you can actually continue by writing this out because you're going to have to find the interval of convergence anyway. Like that. And then you'd subtract 2 from both sides, so you get -4. X is between -4 and 0. Okay. So now you test endpoints. So when x equals -4, what actually happens? We would get, plug in -4 for x here. So that just becomes a -2 to the n. So you'd have a -2 to the n over 2 to the n ln n. So that would look like a -1 to the n over ln n, and you say converges by the alternating series test. Then you plug in x equals 0. And if you plug in x equals 0, you would get right? The denominator is smaller, so the overall thing gets bigger. And so that diverges. So here you can finally say the final answer. The radius of convergence is 2. And again, that's because if you're on this interval between -4 and 0, half of that length is 2. And at the same time now, the interval of convergence is going to be including -4, but not including the 0. So hopefully that answers your question. So whenever you're finding radius or interval of convergence, it's always the ratio test. You find this limit. You're going to go through, you're going to cancel common terms, you're going to find the limit. You'll have something with x's in it. You'll be able to set this up as an absolute value inequality, solve for x's, then you test the endpoints in the series. Using your series convergence test, you should be able to quickly determine whether these guys converge. And by plugging them in here, then if it converges, you include that in the interval. If it doesn't, you don't include it in the interval. The radius of convergence is just going to be half the length of that interval. So there's a length of 4 between -4 and 0. So the radius of convergence is half of that, which is 2. And since we're right here, I'm on that same page. I believe someone asked me for problem 7 earlier. Did anyone actually get problem 7? Did anyone do problem 7? Or ideas on how?
Oh, I
Hello?
think I got it.
Yeah, what did you do?
Hold on here. Well, I compared it to that function is less than 1 over x, or the integral of 1 over x, rather.
Yeah, so you have this guy. Now e to the minus x is positive, right? So if you add an e to the minus x in the denominator, so you want to compare it to this guy here will have a larger denominator because I just added a positive number. So if it has a larger denominator, that means it is a smaller fraction. And so that tells you that this goes that way. And it is known that 1 to infinity of 1 over x dx diverges. Now you could actually compute that directly, but we know that 1 to the infinity of 1 over x to the p diverges whenever your p is less than or equal to 1. So you should know. So this means, let's call this I. I diverges by comparison. So yeah, good call. comparing it to 1 over x.
Could we do number 4 as well?
So by adding the e to the minus x in the denominator, I created a larger denominator, hence creating a smaller fraction, and I created a guy that we know what happens. Number 4, you said?
Yeah.
Okay, let me snip this here. Okay, so that's the one on parametric curves. That's the one you want?
Yeah, please.
Okay, so you want to find the equation of a tangent line. So you always do that the same way. You find the point and the slope. And for part A, we know how to find the slope. dy dx is equal to dy dt over dx dt. So my y here is t squared plus 2. So dy dt would be 2t. My x is 1 plus ln of t. So my dx dt is 1 over t. So this just gives me 2t squared. Okay, so that means when t equals 1, as in part A, this means the derivative, the slope, is going to be 2 times 1 squared, which is 2. Use that as the m in my tangent line. The point, when t equals 1, this means my x is equal to 1 plus ln of 1, which is 1, because ln of 1 is 0. My y would be equal to 1 squared plus 2, which is 3. So this means that the point is 1 comma 3. And then I would just point slope form. Y minus 3 equals m x minus 1. That's my tangent line. If I move on to B, determine the concavity when t equals 1. So concavity just comes from the second derivative. So I want to find the second derivative. And you might remember this is just the derivative with respect to t of the first derivative over dx dt. So that's going to be d dt of 2t squared over dx dt, which is 1 over t. So this is just 4t over 1 over t. So that is just going to be 4t squared. So when t equals 1, y double prime of x is going to, of whatever the particular x is going to be 4, which is positive. So this means it's concave up. Set up an integral to find the arc length from t equals 0 to radical 3. So for part C, you just remember the formula. It's the integral from a to b of the square root of x prime squared plus y prime squared. So this is 0 to radical 3. If my x prime was 1 over t, my y prime was 2t. And so that'll be it. That's problem 4. So you have to know the formulas here. So dy dx is dy dt over dx dt. Gives me a nice derivative here. To get a tangent line, I need a slope and a point. So I find the slope by just plugging in the t value into the derivative. And I find the point by just computing what is the x and y coordinate. And then y minus y1 equals mx minus x1. For concavity, that's just determined by the sign of the second derivative. If the second derivative is positive, it's concave up. If the second derivative is negative, it's concave down. So here, the second derivative was 4t squared. And so when t equals 1, that's a positive number. In fact, that's going to be positive always. And this is a formula for arc length. And so we have that. So I assume that answered your question.
Yep, thank you.
All right. Okay. Any other questions, concerns?
I have a question about 5B.
5B. So that is one of those series thingies. Do they converge absolutely or? Oh, you guys are here. You're hearing me, right?
Yeah.
Okay, good. So so for this, I'd basically just say, we know that the sine, not sine of x. This is true. So that kind of tells me that the expression 2 minus sine n over n, well, the most it can be is when sine is -1. So it's going to be 3 over n. And the minimum it can be is when sine is +1, which is 1 over n. And so the sum 2 minus sine n over n diverges by comparison. And I'm specifically thinking of this relationship here. Does that answer your question?
Yeah, so what you're saying is because we know that the series of 1 over n converges or
It diverges. So, and it's smaller than the
Right.
2 minus sine n.
Okay, yeah.
So the guy on the left is going off to infinity. So it pushes the guy on the right to infinity.
Right. Okay, thank you.
Yeah. Yeah, and that's a very common thing. Whenever you see like a trig function in one of these things, you always start by trying to bound them. Try to replace the trig functions with some numbers, and then you can probably do like a comparison of some sort. Yeah. I'm gonna really need to give this computer a break. Been working it too hard. It's like really hot. keeps chip. Yeah, so that was problem 4 and problem 5. B. Maybe as a nice little exercise, we can do like that is 5a. And that this is 5c because we already did 5b, and this is 5d. Okay, so maybe have some fun with this. Let's do like a rapid fire kind of thing. Just talk me through this. What do you think? Tell me converges or diverges and what tests you would use. Go. So for the first one, what are you thinking?
Converges conditionally by
Converges conditionally. Why?
by alternating series.
Mm-hmm. Did you check the absolute?
Well, I guess if it was absolute, it would diverge because you can compare it to like 1 over n.
It would be larger than 1 over n. So a comparison with 1 over n won't work.
Oh.
So you see ln of n over n.
Well, 1
what
over n does diverge. So if it's greater than 1 over n, it would have to diverge, right?
is it? Where? It's greater than 1 over n. So it's ln n over n. So yes, you're right. Yes. So here, boom, diverges with absolute values because ln of n over n is larger than 1 over n. And then we can know converges conditionally by alternating series test. So, of course, to be able to state this, and this is why it's rapid fire, you do have to just write down that you considered the things that would have to happen. So you know that your AN is decreasing and AN approaches 0. And of course, your AN is always positive without the -1 to the n.
When you do the test for divergence with an alternating series, do you just like ignore the -1 to the n?
Yeah.
Okay.
And I mean, test for divergence, yeah, you can ignore any constant factor for that because any constant times 0 would give you 0. So the -1 to the n technically is like a constant. It's like a plus or -1. What about this one? Converges or diverges? C.
Converges.
Converges? How do you know? Converges how?
It converges absolutely. And can't you do a ratio test for it?
Right. So once I see, absolutely, I would think of using the ratio test. And why did you use the ratio test? What did you see?
I saw a factorial.
Right. So when you see factorials, you tend to want to think the ratio test. So yeah, and as well as you could guess that this was going to converge because the top is an exponential and the bottom is a factorial. And we know that factorials grow a lot faster than exponentials. So the terms here are going to 0 really fast. And so eventually you want to think that we're pretty much adding nothing after a little while. This one, D.
That one converges conditionally by alternating series.
Mm-hmm. What about the absolute case?
Well, that you can compare it to 1 over n diverges.
Mhm.
And this one
Or
is,
even 1 over radical n would also work.
yeah, 1 over
Diverges with absolute values by comparison to 1 over the square root of n. And I mean, not even comparison, it's a p series. You don't even need comparison. Just erase this. We don't need comparison. It is a p series once you throw absolute values around it. With absolute values, the series is 1 over radical n, which is a divergent p series. So it's a p series where p equals a half. So this only converges conditionally. Okay. Right. Now, hopefully to see any one of those, it didn't take you too long. But yeah, with practice, you'll see certain things that will pop out. So for example, whenever I see like a factorial, my mind immediately, if it doesn't go to, if the limit goes to 0, my mind would immediately kind of go into ratio test and that sort of thing.
do we have to like draw out the ratio test, or can we just do like a converges absolutely by ratio test if we see a factorial?
You would have to write it out here.
Okay.
So I'm really doing rapid fire here. The only place where I would allow you to just say it converges or diverges and just tell me what test is the situation where you're finding like a radius of convergence or interval of convergence. So like notice like right here, I just wrote down it converges by this or it diverges by that, right? That's okay. Because the point of this problem is much bigger than those two tests, you know? You're kind of using these tests to help you make a conclusion. So I say you won't have to write out the details to things like that here. But if the whole problem is you determining convergence, I want to show that you actually did the work. So you would be writing this out.
All right, thank you.
Yeah. Other questions?
I was gonna ask, we get is there bonus questions like for the ones that we answer, like the extra ones?
Oh, right. So there's no official bonus on the final, but there are choices, as you would notice. So how I would work with that. So the first 7 problems are going to be mandatory. You have to do them. And then you have to do 3. Now, what I do is I give you 5 problems and you do 3. Now, if you do more than 3, it's not going to count extra, but I will count the best 3, you know? So let's say you did 4 problems and you got 10 points, 10 points, 10 points, and then an 8 point. I would actually count the 3 10 points and I'd ignore the 8 point. So if you do more than 3 from the optional section, I will give you credit for the best attempts.
Okay.
So if you're super sure that you got those 3 correct, you can just leave it. But if you want to like hedge your bets, you can do more and just try to get away with the most points as possible. But I'll give you credit for the best 3. So that's the benefit you have here. And you also have the benefit of just like skipping something entirely, which is, it's always nice. So at the end of the day, you guys need to do 10 problems and you'll have 2 hours and 15 minutes. And ultimately you have like an extra half an hour. So the official start time of the file is 1:30, but it'll come live at 1:15. Starting from 1:30, you have 2 hours and 15 minutes. So that brings you to 3:45, something like that, 3:45, yeah. And then you have until like 4 o'clock to upload your answers. And So hopefully by now, looking at the integrals, you kind of see how to approach them. Looking at the series, you kind of see how to approach them. And you can look at a lot more examples there with the textbook. And if you've done a lot of the actual practice and working out, one thing you could do is like the phantom practice. Like I played that integral game with you guys. You can actually get a lot more practice in. Once you know you can actually pull off the arithmetic, then all you need to do is just see the solution. So look through some integral problems and see, would I know the approach to kill this? And look at some series problems. Would I know the approach to kill this? So that's what I was practicing with you guys here with the rapid fire. Just could you look at it and kind of know? So like looking at this, seeing the factorial and know, oh, I would use the ratio test for that. Like that's a big deal. To be able to look at it and within a few seconds kind of know, oh, ratio test is the approach here. Once you can do that, you're going to be pretty good and you're not going to run out of time. What causes you to run out of time is if you're sitting there forever looking at this, what do I do here? Oh, let's try this, let's try that, let's try that. And you're not sure what to try, that's where you'll get in trouble. But if you kind of just see things, you'll be fine. So that's what I would say there. I mean, we're pretty much at the end of the scheduled time, but any parting questions? And also with, I mentioned a couple other websites, see like Symbolab and things of that sort. So if you want to practice any extra problems, any similar problems, you can either practice where you can see the odd problems in the back of a book, or you can type in a problem in Symbolab. So the Symbolab will be able to do the computational problem. So you can plug in any of the integrals into Symbolab and it will actually tell you how to do it, show you the steps, and you can use that as a study tool. So that's something you can always do.
I just have like a quick question on the Maclaurin series ones. Like,
yes,
when
that's
you
problem 10.
Yeah.
Yeah.
Just like after you like compute the integral for like the sum of two factors, like, is it okay if you just leave it as, or two fractions? Like, is it okay if you just leave it as like 1/5 over 166? Just because that's like.
Yeah. Like you don't have to simplify there.
Okay. All right. That was my question.
Okay. Yeah. So, I mean, for that one here, so we know that sine x was the series n goes from 0 to infinity minus 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. And so this would mean that x sine of x cubed would be x times the series minus 1 to the n. You plug in an x cubed in here, 2n plus 1. So this would be the series minus 1 to the n. This is x to the 6n plus 3, but then you bring this x from the outside in, so it's 6n plus 4 over 2n plus 1. So that would be the Maclaurin series for x sine x cubed. And then if you want to do the integral from 0 to 1 of x sine of x cubed, this is the integral from 0 to 1 of the series of minus 1 to the n x to the 6n plus 4 over 2n plus 1. Because of absolute convergence, you can switch these guys. And that's the power rule. So you would add 1 to the power, 6n plus 5, and divide by the new power, 6n plus 5. Between 0 and 1. So you end up with the series of minus 1 to the n over 6n plus 5, 2n plus 1 factorial. And so this is going to be approximately equal to, you just write out the first few. It starts from n equals 0. So it's going to be 1 over 5 minus 1 over 11 times, plug in n equals 1, that's 3 factorial times 6, plus 1 over n equals 2, that's 17 times 120. And so your answer is going to be the sum of the first two terms. And then this one tells you how far you're from the actual answer. So now the error, which is the difference between the sum and the sum of the first two terms, is going to be less than or equal to that guy. So, and then you say by the alternating series approximation theorem. And we pretty much did that entire. So you state the Maclaurin series for sine of x, plug in x cubed and multiply by x to get the Maclaurin series for the other part. The integral, just swap the integral in the series because this guy works with absolute convergence on the entire real line. Do the power rule and then plug in a bunch of terms. Now it asks you for two terms in the problem. So I just, yeah, you can leave it like this, 1/5 minus 1 over 11 times 6. You don't even have to write 66. You just write it as 11 times 6. It'll be fine. And then it says, how close is your estimate to the actual value? Well, you can just tell me the error. That's this guy. How do I know? By the alternating series approximation theorem. So this is less than or equal to A3, which is that. So the third term tells you how good the all previous terms will give you. Yeah, so that would be that problem. Yeah, so, I mean, we're here, so I just decided to like go through it rapidly. Any parting questions before we go? Gonna wrap up here. Okay, well, you have any quick questions for the rest of the day, you can shoot me an email. I'm kind of going to be in and out of class and finals until about 8 p.m. So if I don't get back to you before 8 p.m., don't take it too personally, but hopefully you won't even really need me much before then. Good luck tomorrow. I will see you guys tomorrow, and hopefully I can have a good end to this semester, which has been very crazy.
Thank you.
All right, yeah,
you.
all right.
Thank you.
Good seeing you guys. Hope you're safe. Be sure to get a good night's sleep tonight. So don't decide to stay up all night and do anything. That's probably not a good idea. And make sure you have something to eat before the final. So try not to like drink a lot of coffee or anything, and anything that might let you go to the bathroom, but have a good night's sleep, be very rested. Worst thing you want to do is like go into a final like this tired, because then you'll make a lot of mistakes. Yeah, like earlier I made that, like I'm working these things out in real time with you guys. So now it's like that 1 over n thing caught me earlier, but I think Quinn, was it? Maybe Quinn saved me. Yeah, so anyway, do that. Good night's sleep. If you went through the practice final, you should be fine. It's going to be very similar. Not going to throw any curveballs. So you know how to deal with those problems. It should be fine. As well as, I believe I put a handout for series on the class website. Let me actually double check that. Which you guys might want to look at. I posted it on the website. I don't think I got a chance to hand it out in class to you guys. But if you go to the bottom, yeah, so there's a common series test handout at the bottom. And it's nice because there's a middle column that says when to use. So that actually covers all the things that I actually mentioned in class here in a nice little table. So earlier when we said that, oh, because we see factorials, we think the ratio test. So there's the table will tell you that in the middle column, and it tells you how to actually do the test. So it's a nice little summary that I put in the sheet here, just to help you review quickly. With that being said, we'll end there. Good luck, guys. I will see you tomorrow. Bye.
Jhevon,
Yes,
grading test 2?
it's not going to be graded before the finals.
Oh, okay.
Yeah, but if everything will be graded, and I'll let you guys know what's going on.
Okay, sure.
All right.
Yeah.
Bye.